Hello friend, welcome all of you in my Learn and Grow series episode 4. So today I discuss on single solid principle. So A stand for single responsibility principle, O stand for open close principle, and L for risk of substitution principle, I for interface segregation principle, and D for dependency inversion principle. So, single responsibility principle states that a class should have only one reason to change, meaning it should handle a single responsibility. So, let's assume there is a class user, and on that class there is a method. Let's assume that get name, and there is another method log user activity. So actually it is violate the solid principle, that means single responsibility principle, as because here the user class must be responsible for user related things. We should split this class into two class. That means user related things we keep in one class, and the logged in logger activity related things we keep in another class. And after that we inject the logger activity things class in user class, and so then it will fulfill the single responsibility principle. That is the better approach. Next we discuss on the open close principle. So in open close principle, software entities should be open for extension but close for extension. So here during development time, we should be careful that when we design in on that time, it should be open for extension. Like let's assume there is a payment processor, or let's assume public function on class payment processor, and there is a method let's process. So and payment type is one argument on that. So based on the payment type, let's assume that if payment type is credit card, then we write some credit card related process logic, and if it is payment, else if payment type is equal to PayPal, then PayPal related things. In this way the current class, but it is violate the method open close principle, as because in future if we want to add many more particular payment processor like phone pay, google pay, apple pay, on that time many more else if we have to introduce. So maybe on the existing system where this class already we used, so on that time there is a chance of breaking these things, and it will taking task testing time also, or taking very much more. So it will be better that we design in such a way that it will not break down the existing system, and testing also easy to maintain. So what we can do, we just create one interface, common payment process is one interface. We just payment, say for example interface payment method, and after that public function process. And after that what we doing for credit card payment, we just create class credit card payment implements and the payment method. Similarly for PayPal payment, class PayPal payment implement the payment method where we implement the process method. So in future there is Google Pay we need to integrate. So again we just again integrate one and add one class and implement the payment method interface. So in this way it will not changing on the existing class. As so open for extension, so as many as payment processor we can add. For that we not changing anything on the existing code base. So that approach is open close principle. Let's move to Liskov substitute principle. So Liskov substitution principle, it says that subtype must be substitutable for their base type without altering program correctness. So any interface is replaceable without breaking the logic. So let's assume there is a class, say for example bird, and there is a method, let's assume fly. So if any another class extend this bird class, let's example penguin class, penguin extend this bird, and for penguin in I have to implement this fly method where it is through error, throw error, as because penguin not fly. So it's breakdown, that means subtype must be substitutable for their base type. So what we can do in this case, what we can do, just simply we the abstract class bird, we create one abstract class bird and abstract public function move. Instead of fly, abstract public function move. When this abstract class, suppose class sparrow extend bird, so for sparrow we implement the move method and it is flying. For penguin, in move method we return swimming. So in this way, actually, what we can do easily, we can implement, and for any class it is not broken. So in this way we ensure that Liskov substitution principle will not broken. Similarly, interface segregation principle. Interface segregation. Let's discuss on interface segregation principle. In interface segregation principle, clients should not be forced to depend on interface they do not use. Let's say, for example, there is a interface, workable interface, and on that workable interface there is three method. One is work, another is eat, another is sleep. So three method under work interface. So any class when implement this interface, he has to bound to implement work, eat and sleep three method. Let's assume a human worker one class implement this work interface. So for human worker, we implement the work method, eat method and sleep method. So as because this three method is valid for human worker, so it's fine. So but when we implement a class robot worker and implement the work interface, on that case robot actually not eat not sleep. For robot, when we implement the work method it is fine, but for eat method we have to write something throw new exception, and for sleep also. So it is violate the particular interface segregation. In this case, if we split the larger interface into small role based interface, then it is support the interface segregation principle. What we can do in this case, we can do we can implement three interface, basically workable interface, eatable interface and sleepable interface, and for each and every interface we keep the method work. There is three interface: workable interface, eatable interface and sleepable interface. Under workable interface, work method, and eat under eatable interface there is eat method, and sleepable interface there is sleep method. After that, when for human worker we implement three interface at a time. That means implement workable interface, eatable interface and sleepable interface, and we implement the three method work, eat, sleep. So it's absolutely fine. And but for robot worker, class robot worker implements only workable interface, as because eatable interface and sleepable interface is not required to implement here for robot worker. Just public function work, yeah, like echo assembling parts. So in this way we solve the interface, just implement the interface segregation principle. And dependency inversion principle. Actually, high level module should not depend on low level module. Both should depend on the abstraction. Depends on abstraction, not on concreation. So let's assume there is a class MySQL database and there is a method public function save. So saving the MySQL. So this is the class. After that, one class user controller, and where we private is database, and we write a construct, and where we create a new object of MySQL database, hard coded new MySQL database on that user controller. And after that there is a method create user, where we pass the user data and it is saving the user data. $this database save user data. Here in future, if is there any requirement to change MySQL database to PostgreSQL or SQL Server? On that we have to directly change on the user controller class, which is a direct dependency. So high level module should not be depend on low level module. Well, both should depend on the abstraction, so it's violate the rule. So in this case, if we design the particular interface in such a way, if we interface just design one interface, database interface, and under this database interface we write down on method save, and after that class MySQL database implement the database interface, and the method save is implemented. After that class PostgreSQL database implement the same interface, database interface. In future SQL Server coming, then class SQL Server implement that same database interface and develop the method. So on that time, if in user controller or if we construct and we just pass the interface in construct method, we inject the directly. In earlier we hard coded the MySQL database there, but here we are just inject the interface, not any database. After that, when we just create one uses is on that time, what we are doing, just create new MySQL database or new PostgreSQL, and after that in new user controller, or we pass that object. In this way, a dependency in inversion principle we can manage. So it's in this way actually abstraction database interface and device high level depends on standard power socket interface, not specific outlet. You can plug into compatible socket worldwide. And benefit of dependency inversion principle: decoupled code changes to low level module. As for example, database don't affect high level module. Testability, the mock dependencies, as for example, use a mock database for testing. Extensibility, add new implementation, as for example MongoDB database, without modifying the existing code. So this is the advantage. So we should where actually the solid principle is, it's a class based object oriented programming. We should it's the best place when we develop any object oriented programming. On that time we should keep in mind that we follow the solid principle, as that after developing the application we don't need to be panic when we try to application scalable. From the beginning, if we take care this small thinking things, so with time when data will grow or user will grow, on that time it will not create any trouble. So that is solid principle for today. Bye bye, thank you.